A couple of contentious things. Some of them are like feature additions. So like the obvious stuff like this thing is just patently wrong, right? Like, I don't know. What's an example of that?
You haven't got it
there's
up
typos. There's typos and things, right?
You haven't got it up on the screen yet.
No, I'll put it up. Oh, hang on, oh, you got to press VGA or whatever.
Yeah,
Source.
select, yeah, source.
I haven't any times. Do that. So anyway, it'd be good to go through this. I'll document it on the wiki as well, what the outcome of the discussion was. And then what we do after that, I don't know. Probably do a new release of the architecture document, right?
Mm-hmm.
Disable, enable.
And I apologize for messing up the draft.
Ah, no, you did well, Jan. What are you talking about? You did very well.
Well, I think the biggest mistake I made was changing instruction classes by the implementation instead of discussing it.
Changing the instruction classes by the, what do you mean?
I think some instructions were optional in the OR1200, so I assumed they should be.
Ah, yes, okay.
HDMI cable.
Ah, right, okay.
No,
Yeah.
I have a picture.
That's not very big though. So, wait. That's okay.
OpenRISC is taking over. I think you should try something 4 times 768. I think it's a bigger picture.
Should be able to get a widescreen now.
Ah, look at that. Oh, yes.
You were grabbing rats too.
Yeah. Just went into the GCC. So there's only really,
Only one contributor.
yeah.
So no problem.
Anyway, there's only basically Matt Yaz, Damian, Marco, and the other people are in the room. So.
And the param and return guys.
Yeah.
Alright, this is good then. I have some sort of. Oh. Doing well here. Oh, LinkedIn. Okay. F11.
Almost, I should say. It's the right side.
Yeah, how do you make, is it just open cores? How do I make it wrap?
Make it smoother.
Ins and out.
You are wrapping. It's just your window is bigger than your You see, if you
No,
scroll,
the
you've got a scroll
page
bar.
is wrapping. It's not wrapping to the window. It's sort of
The
annoying.
window's okay.
Yeah, I think it's an open core issue.
Yeah.
Can people sort of read that? Oh well.
Start sheet.
You just go to opencourse.org/OR1K and there's a link to the architecture page. On that page is this list. So we'll go through it. First of all, there's a bunch of typos and clarifications, I guess. So what's that? That first one. Cache. Alright, yeah. These registers in the cache are marked as optional, but maybe shouldn't be. Is that right? Like,
Is that related to? There's another bug that Jeremy filed about when you disable the caches, you can still write to them.
oh really?
Yeah, it's one of the ones I filed in the bug squashing session. So we might have some problem there.
Is that a big deal?
There's
Apparently.
some part of RTL that changes behavior based on those registers, and then the cache isn't there, so the behavior is something strange, I think.
Yeah.
And I filed a bug on that.
Yep. Or you might have just moved it from.
Yeah, yeah, it's probably me
But I think
setting
it
up
was.
the bugs in
I
it.
think
Yeah.
you wrote.
Oh yeah, there's loads of the old bugs are listed as me because I transferred them from the old bug tracker.
Alright. Fair enough. Optionally implemented. So you need the flush registers. Alright. Well, does everyone agree with this, at least this one? Basically, these registers, you need them. There's no way they should be optional. So the proposal is, so it's the data cache control register, data instruction cache control register.
No, I think there is an instruction function present a bit for them already, so you don't need those registers if the cache is absent.
Where?
It's
Hold on.
No, I think the argument is that you have to have those registers if you have the cache.
yes.
That makes sense.
Yes.
Sorry, that's what I meant to say. I said something else.
Yeah. So if the present bit is set, then these have to be implemented.
Yeah, but there's but the point is that I think
What is that
they
could be optional?
there's bits.
They are not.
Yeah. There's bits to say whether these registers are present. And in the spec, they're listed as optional. But there's no way these registers should be optional.
If you have a cache.
Yes. Yeah.
All right, make it clear. Yes. Yeah. If you have a cache, those registers must be there.
No, them being optional, but rather than
Yes, so they're
being
optional.
mandatory one.
Yes, you have not
So-
connected the optionality to the presence of the cache.
If you have the cache, you have to have these registers, basically. Well, if you have an instruction cache, you have to have at least instruction.
Yeah, but what it says is that if you don't have, you don't need them. That's
Yeah.
what the whole thing. Isn't that what the whole thing is about? The whole.
Yeah. Let me. Where should I put a discussion page here?
Well, this is the talk page, right? No.
No, this one isn't. Where?
What on? Do you want someone to be taking some
No,
notes?
I'll do it.
That's
That's fine.
fine.
That's fine.
Yeah.
It'll be simple to do. I'll just. Do it log in.
Well, why not do like we did last night and get someone other than you, because you're chairing, to make the notes?
Because it'll just be like a simple, this issue we agreed on. That's all I want to write.
I was
somewhere.
quite happy with Simon doing it. If you want to.
I'm happy to do it because then everyone can see what I'm writing.
Okay.
Where was, so, should I make a new page or something? Meaning discussion?
Well,
Project
Do it,
meeting.
do it on the discussion page of the architecture specification.
Alright, let's do that. Oh, the discussion page of the architecture spec.
Yeah.
Alright.
So top of that page, go to the discussion.
Discussion, we'll start this up then. Okay. Discussion at OpenRISC project meeting. October 2012. Good.
Try putting 2 equal signs on there so you don't confuse Media Wiki.
Yep. So, first issue is agreed that these registers should be marked mandatory. Well, agreed that proposed. So the proposal is that the presence bits in these registers should always be marked as 1.
I think you need to make it clear that if the cache is present, those registers must be present, and I think that says it very clearly.
The text is, specifies the block invalidate and block flush are mandatory, but the other 3 in the point clip in here should be marked optional. Is that the proposal?
If you have a cache, you should have all the cache registers. If you don't have the cache, you don't need the cache registers.
But this is more nuanced than that. It's if you have the cache, These registers are not optional.
That's what I just said, isn't it?
I don't know.
It feels like we've been saying
Mandatory is the opposite of
exactly
not
same
optional.
thing for like 15 minutes now. Everyone know what we mean.
It's just
Instruction and data.
It seems that everyone knows that nobody was brave enough to just edit that without having a discussion. Actually.
Alright.
Well, we did go through a period when it was very hard to edit the architecture manual. It was felt to be a sacred sacred text. And,
Yeah, not anymore.
I started reading it and found a lot of inconsistencies, and I don't like that in my sacred text.
That's usually with sacred texts. Unless we can have some apocrypha that is like, not officially used in any.
we now have people with divine status who are allowed to edit.
Ah, sorry, it's on this screen. Let me pull it over here. So we're talking about in the cache model, cache special purpose registers. Control things, right? Okay. So it reckons, well, it's going to look like just double check what this thing's on about. Inconsistent use of optional tag in ArcSpec cache. Section 9.2. Optional label is applied to some of the instruction and data cache registers that have implemented fields in the cache configuration register. So you can check if they're there, right?
So what this bug seems to suggest is to specify for each register that it is optional since there is a presence detect bit.
Yep.
But we seem to be disagreeing with that a bit because we see some of these registers as essential to having a cache.
Yes. Yep.
It's things like 9.2.5. The title is data cache block lock brackets optional.
Yeah.
Yeah.
And I don't think we actually have locking currently, so that
So that-
would be optional.
So that even if you have caches, that one is optional.
It is, however, useful. U-Boot uses that feature on a number of devices just to have a bit of memory, the cache, when it has not initialized the RAM.
So I think it's in the configuration register, right? The instruction go away table thing. In the instruction cache and data cache configuration registers. Control. Where's the register which says, yeah, DCCFGR, DCCFGR.
Let's see.
This thing. There's a thing which says,
The configuration register you want.
Yes, it's in another section.
It's
of
in
the
section, it's in the thing about
15.
features.
yeah,
15.
convenient. So, cache block flush, for instance. Is this data or what? Which cache is this? Data. You need this one all the time. Okay? If your cache is enabled.
Yes.
And so we're saying the block invalidate for instruction and data and the data block flush are mandatory, and we should always lock their bits in this single one.
Yeah.
Except
Except if you don't have a cache.
if you don't have a write that cache. then it-
Ah, alright, this is an interesting point. I think you still...
But I don't know if we have to make an exception for that. It's like
Even with the write-back cache, you need the invalidate.
Yeah,
Yeah,
you need
yeah.
to invalidate. Yeah, block flush is probably unuseful in right back.
So the
Yeah.
configuration bit
Right
stays
through.
there, but you've written it to what?
it's or what did you say?
Right back. The one where it only gets written to the cache.
Yeah.
You need the block flush to
Yeah,
make
then
sure.
you need a block.
Yeah.
Then
That is not optional in right back.
But I don't know. In a write through, they mean the same thing then. So it's you could easily just map them together. And
Yeah. Just have the same functionality. Anyway, This is good. Progress. So that's all we're saying. That these ones are optional and these ones are not if you've got a cache and should be marked as such. So we agree that, right? We agree? I'm taking silence is approval.
Well,
Sorry to labour this point, I just want to get it clear. And then we go. So
I guess block invalidate and block flush may be the same thing on some caches, but they should both be present.
that's not right. What I wrote there is not 100% right. So suppose that spec is changed to agreed with the proposal on the main page, which is their presence bits in these things should be marked as always 1. And I'm not sure if go away table thing. Go here again. Are they marked as optional in this bit of the document? So block and validate, for instance. Data cache block and validate. Prefetch. Flush. Doesn't say it's optional. Doesn't say it's optional. Alright. So yeah, we just mark in the CFGR that is marked in the XCFGR that their bits are always 1 in the presence of a cache of as these registers are not optional. I think that's all we need to do. Good. Next thing. Alright, so GPR 0 usage is another interesting one.
Oh, we're on the next one now.
Yep.
I think it should be 1.
I think so too. And if you
Yeah,
want,
that's a lot more interesting.
It's a lot of things on the MSP 430 where there is a constant generator. It can generate 0, 1, 2, 4, or 8.
okay.
Oh, that's good. Really good.
Or
Alright.
-1.
To eliminate confusion regarding the behavior of writes to R0 when it's hardwired in implementation, the mention of its role, according to the ABI, and the potential implementation shortcuts should be removed. Now, wow.
So the reason you have it in some architectures that you can write to it and it's ignored is it allows you to use instructions with side effects, such as instructions that set flags and throw away the result. So it can be very useful. But I'm not sure if that's of value to us in our architecture. It gives you a whole load of more instructions, which in some architectures you actually need.
Very little. Basically, the flag that we are using, which is the flag, is
Yeah.
only set by the set flag instructions.
So it's not terribly
So
relevant.
what's left is the carry flag, but that's not really used. Could be used though.
It should be used for 64-bit operations and such. I
Um,
don't know how that's solved currently.
So we do have a carry flag as well as a.
There's a lot of confusion about the carry flag and the overflow flag.
Yeah, I mean,
Yeah.
having it hardwired to because at the moment all the implementations at the moment do hardwire it to 0, don't they? And
look,
Oh, the R0.
sorry,
You're speaking about
R0, yeah. So that you can write to it and have side effects. If you want to generate the carry flag without the result, you can do.
all we're doing is removing language to make people think that they should do it one way or another, right? We want to almost make it more ambiguous. No. Like, at the moment it says R0 is used as constant 0. This is what it says in the document. Whether or not R0 is actually hardwired is implementation dependent. It should never be used as a destination register. And this is early on in the document, right? So we want to replace it with we want to say use of this register is defined in the ABI section. We are not going to define it here, right? Which I think is a good thing to say because I'm not sure you should be defining ABI stuff early on in an architecture spec. You're saying you got 32 registers. Then later on we add that it is fixed to 0. Even if it is writable in some implementations, the software shouldn't modify it. So that's what we're proposing that we add in the ABI section.
Right.
Oh no, sorry. We're
That's
saying
what is-
what is there, and we should say R0 holds a 0 value. So it's like, we're not saying this thing should be hardwired to 0. We're saying as far as the software is concerned, it holds the value 0.
I think you need to be clearer than that because I've certainly seen some architectural proposals that says you actually have to explicitly set it to 0, otherwise it has some random value in it.
Are we going to get into how you initialize your hardware though?
Well,
In
it's different.
the
Yeah,
API?
saying R0 holds a 0 value
Yep.
is slightly different from saying R0 should hold a 0 value. In other words, you've got to say, are you placing responsibility on the software engineer to ensure it holds a 0 value, or the hardware engineer?
I think you are, because this is in the software
make it
API
clear.
section.
Yeah, well, no, make it explicit. Don't make it ambiguous. You know, if you mean it is the responsibility of this software to just say it clearly. It is the responsibility of the software to ensure that R0 is initialized to 0.
Yeah, I
And you
agree
make it
with
very
that.
unambiguous.
Okay.
And then it doesn't matter, is it hardwired or whatever.
Yeah.
But of course, yeah.
But in the architecture session, because you're changing what it said before, I think there ought to be some reference to say that, to make it clear that what went before. You can't just take it out because people will say, I'm sure I read this in the past.
Yeah.
So it will say R0 holds a 0 value. It is the responsibility of the software to initialize it.
Yeah.
So isn't that like a hardware accelerated dev null then?
Sorry.
It would be if you could write any value to it and still have it remain 0.
Yeah,
Yeah.
that's true.
Could you put always in front of the holds, just to make it clear? Or should always hold?
Or should.
Always hold.
Okay.
Okay.
Is everyone happy with that?
Yeah, but I think in the hardware section you still need to actually have some reference that allows people to clarify what they read in the past. Okay, because
Like a mention of the previous.
yeah,
fact that maybe-
Say previously there were requirements, or the previous version of this document had requirements
Yeah.
on the value held in R0 set in by the hardware. This is now solely a matter for software and is discussed in the ABI or something like that.
Mention the previous R0 statements
Because
regarding implementation.
the specification did say that R0 should never be written, and that is different from
Now it
real
shouldn't.
life
It
usage,
must be written.
which is that at least on boot up it must be written with 0.
Yeah. And
Or check that it has 0 if you really want to be pedantic.
I mean, I think this is fine because even, well, people shouldn't have in the past, if there's another OpenRISC processor out there that somehow completely freaks out and calls an exception on write to R0.
All the old software tests used to assume that R0 had 0 in it. They didn't initialize it. The old RTL tests. didn't
Really?
Yeah, I'm pretty certain.
Yeah, we have not having this problem.
Yeah.
Okay.
And I think it was Ruben actually changed stuff to actually make the tests explicitly put 0 in R0.
The RTL you had to though. Otherwise it was X. Like in,
Oh yes, that's
very
what I
old
mean. Is
simulation.
in the old RTL, the RTL did set it to 0, so the software didn't need to. But
No,
now
no.
you're saying it's the software's responsibility to
Yeah,
initialize
yeah.
it.
No,
so
I'm saying the
could
hardware could have done it. The old spec allowed you to say,
yeah, and all the,
allow people to hardwire
yeah,
it to
and
0.
all the old RTL tests assumed that was the case. So if you ran the RTL tests as they were on an implementation that initialized it to 1 in hardware, leaving it to the software to initialize it, they would all fail because the old test did not have a
Yeah.
load 0 into, or
Fine. So
Another
Because it was forbidden by the spec. Software may not write it.
Yeah.
Yeah. Well, this is clearing it up, I think, and I do think, and my point was that I don't think this is going to break anything either by saying that. It's just another register. The ABI wants it to be 0. Otherwise, do your worst. So I think we should add something saying that it was previously different, and now is like the way it is. So it also needs something.
Yeah.
In the hardware section I mentioned the previous R0 statements regarding implementation and use, but that is now changed or something. So just mention that it was like that previously.
completely different discussion, but what's the actual benefit with R0 for us?
You know,
When,
Yeah. Well, having R0 set to 0.
yeah,
There is our compiler balance, but setting a certain number of registers predefined to small constants makes for much more efficient code. Otherwise you have to set R0 to 0 when you want, or you have to set a register to 0 when you want it. And there is a trade-off, it's very architecture dependent, on reserving a register for certain values.
Fine.
Some architectures reserve -1 because it's hard to set -1. Some reserve 1.
But
yeah, but for us, we have, is there some instruction that you can't move or use a 0 immediate?
Sorry?
The problem is all the instructions that use an immediate also require a register that they are modifying. So all the values, all the 16-bit values, for instance, use R0 and or something into it, or add it.
so you still need a clean register.
Yes.
It is very advantageous to have. I mean,
You could clean one up at that point.
Yeah, I get what you, yeah.
yeah. But
I mean,
also,
if you look at something like Epiphany with 64 registers, it has 4 registers reserved for holding constants because it makes for more efficient code. But it's got 64 registers to throw in. So
yeah.
And
And we got 32. That's still a lot. So having one set to a constant isn't too bad, I reckon.
Has anyone used them all?
I actually was having a discussion at work the other day about this, and the guy was like, it was my argument that OR1K didn't use many registers. I bet that it didn't even go into the 20s or something. But then I went and just disassembled a hello world. Or this thing, right? We'll look here, and then we'll see that there's certain functions which do use like R20 or something.
GCC is very good at using lots of registers if you
big
have them.
function is using all these registers, the high registers. So
its reason for using some of them is the spread in the ABI of call E versus call versus registers.
yeah. So I agree, but it does appear to use a wide range of the 32 registers, or a high amount of them. So that's a good thing. And I assume that means less putting stuff on the stack. Very good. Anyway, R0, hopefully solved. Okay.
Finally, that took like 2 years or something.
Yeah.
So it's a change of.
I bet you, I
text
don't
section
know,
for-
Jonas or someone's still gonna come along and say like, but you're gonna break previous implementations or something.
Yeah, but apparently he broke some ABI stuff.
Oh really?
Yeah, with
I don't know, I think that actually has been in GCC for a long while, the R10.
The trap condition, this is one thing that Ruben brought up in the mailing list recently. I think this is pretty straightforward. To explain what it is, in the trap instruction, there's an immediate where you specify a bit to test in the supervision or supervisor register to determine whether or not you trap. And no implementations do this, and there's no sensible reason why it does, so I think we should just say that the trap traps.
But
Conditionally.
so what do people generate at the moment? What's the K value they put in L.trap?
0 or, I don't know.
Because there is a fixed 1 in the status register, which will be the obvious one to use.
Yeah, I know, and that's what I started using, but I just think it's silly. I don't know why you'd want to trap based on bits in the supervision register. No implementations do it, and It doesn't make
Where does it come from? I
But
guess
the fixed one is number 15, so
Yeah. L.trap 15. Yeah, L.trap 15 will be the right one. It will be.
It requires an encoder and test in the RTL, which isn't there.
I mean, I could conceive of uses, say, when you've got an SPU, to have a series of system calls that only happen
if the FPU is present. I mean, I can see why it could be useful,
The FPU presence isn't marked in the supervision register.
isn't it? Oh, right. Okay, right. That was it.
Yeah. No, there's no reason for having this.
Register is
I'm not accepting any argument for it.
I guess I'm only arguing devil's advocate on this on the
Yeah.
grounds that changing an architecture for the sake of change, even if it's wrong stuff in there.
For the sake of future implementations, looking at the architecture spec, and then doing something which then isn't compatible with the rest of the implementations.
Well, if we're sure that it's never been used,
Yeah.
then
This makes sense.
we've never seen it implemented or used.
well, I'm sure there's a reason for it, and it's probably because it's in DLX or MIPS.
Well, no one can think
Yeah,
of it.
exactly. Where does it come from? It probably is, let's say,
Because
on MIPS or something.
Yeah.
But what?
Hang on, let's have a quick look. Well, you carry on.
the background.
Immediate load instructions, only loading high bits.
I haven't looked at the.
So this is a controversial one. The removal of the final letter from the load word assembly mnemonic. Because on 32-bit, and let's face it, I don't know who's doing a 64-bit OpenRISC implementation, but
I think it's good.
That might happen. I wouldn't rule it out.
No,
The compiler part of it would be fun to do.
The
Really?
implementation I've been planning actually can scale to that, but I haven't started writing it.
So, this was just a thing which someone proposed. I think it might have been, actually I can't remember what it was, but yeah, it just makes the code neater because you're specifying a 0 extension on a word that, it doesn't matter on 32-bit.
But then and my very strong argument against this is as soon as you get a 64-bit code, you have assembler source that behaves differently, that actually is semantically different.
No, you specify that it means 0 extend on 64-bit. And then you still have...
Oh, no, that's
it's just
mad.
an alias for load word 0.
No, it's a confusion. It's a confusion and disaster
Not if
waiting
you
to
state
happen.
it. Not if you say in the spec. You can,
No,
in the
that's-
assembly we can have also L.LW and that means load word 0.
Well, if you're going to do that, then you must have LH and LB, as I say, for a load, it being synonyms for load half 0 and load by 0. That if you leave the Z off, the default if you leave it off is Z. And
Yeah.
Okay, if you want to do that, then that's at least consistent.
Right.
But otherwise, I can just see.
I don't see the point of changing that.
No, nor do
Yeah.
I. I mean, I think it's change for change's sake, and I can just see all sorts of things that can go wrong, and I can't see why, since it's a machine generator, you can't stick with what you got.
Currently, the only problem is that the OR1200 only implemented one of
Yeah, well,
yeah,
so
so-
signed on the
Now we fixed that. haven't we?
You fixed it's not even fixed because it's one of those bugs that just plays around that haven't been
Because it actually doesn't
That's a
affect
trivial
anyone.
example. Yeah. But yeah, I totally agree. I don't see the point neither. Like just put that patch in and that's it. I would say. If you're gonna change something there, then say that LWS isn't needed on 32-bit implementation. That's the only thing that if it would change. But I think it's good.
Yeah.
As, and
Ah. I will go back to the trap when we finish this discussion.
Alright. Maybe, I mean, it's obvious that load word signed and load word 0 are equivalent on 32-bit. I'm not sure you should say you don't have load word signed though. I think that's, you're going to have a situation, or you're going to have tests for that and checks for that, right? I mean, I reckon you just leave it as it is. This seems like change for change's sake.
I feel out geeked.
What?
I feel out geeked.
Alright. Sorry, Jeremy. Trap it.
Well, it seems to be looking at. I'm very quickly looking at the MIP stuff. That the reason MIP's using it is to allow you to control whether you're going to trap on things like overflow. Okay, do you want to?
Yeah.
Okay,
we have
which-
the range exception for that.
Well, I mean, maybe we don't need it, but that's why, that appears to be why it's in the MIPS architecture.
Yep. So for overflow, we
And
have
divide, you know,
divide by 0, stuff like that.
yeah, so maybe we don't need it, but
That would be potentially useful if you mark places where the calculation is important, if it overflows or not.
well, the various standards have loads to say about that.
There's no good reason for it, and there's no implementations which support it. I can't think of any reason why you'd use it on OpenRISC. Why have it the way it is.
Oh, here we are. I've got the list of traps for information on what the different trap codes do. It's all different on MIPS.
Maybe you could trap if your instruction case is turned on.
I'm
or
not really
something.
arguing against it, I'm just trying to understand it.
Maybe this is a really quick way of. No, that's stupid because you.
We'll probably, once we've got the first implementation that doesn't do it, we'll realise why it was so important.
No, all implementations don't do it. So, and we all understand why it's not important. Okay, unused SPR space reader 0. I think this is just a clarification we need to add to the architecture spec. And it's a very good one because it means we can test for things that we're yet to implement.
It means we can make new configuration
Yeah,
registers.
yeah,
for,
that's good, yeah.
Thousands of blocks.
Very good. Should have this. Okay. ABI, returning structures by value. Currently, the description for returning structures by value says, a function that returns a structure or union places the address of the structure or union in the general purpose RV register. This should be extended with the following information. A function that returns the structure by value expects the location where the structure is to be placed to be supplied in the function parameter word 0R3. Returns the structure by value expects.
So the way you, if you want to return a structure, the way you do it in, and I think it's the way we do it, I think it's just saying what we do anyway, is you actually say where the result is going to go, you pass as an address as a hidden first
Right.
parameter. And this says that, all we say is that, oh, well, the place is coming back in RV, but we don't actually say you should have been passing it to it. So you end up with R3 and RV having the same value.
Yeah?
It's just making it clear.
Yeah.
I don't think it's,
I mean, where does this come in, just out of interest, where does this come into play in GCC or something? Or?
yeah.
And
Yes,
I noticed it when I did the LLB import because
Uh,
I looked at the AB and trying to get that to work, and I noticed that, or understand that how you have to do it, but it's not stated in the
Right,
spec how you should do it. So
The issue is where does the storage come from, and the caller needs to access the storage, so it's
it'd better have
fairly
it.
reasonable for it to allocate the storage.
yeah.
we all agree this is a needed clarification. Alright, let me save this real quick. And you can all see. See.
364 bits in size. That's impressive.
What?
No, it's the next song.
Yeah,
Mm.
that's a doozy of a register. This is just typo, right? Yep.
Yeah.
Yes, fine. Versioning. Oh, alright, this is my thing.
Flame.
We all love a bit of versioning, don't we? Okay. We don't really have a way of tracking, as far as I recall, implementation information or.
What's the current version register?
It's like silly.
No, yeah, a version register.
Mm.
It's 32 bits. It has 8 bits of version,
Yeah.
8 bits of CFG, 10 bits reserved, and 6 bits of revision. A 6-bit revision is a 6-bit number that identifies various releases of a particular version. CFG is an 8-bit number that identifies a particular configuration, and an 8-bit number that identifies a particular processor version and version of the OpenRISC architecture. Values below 0x10 and above 0x19 are illegal for OpenRISC 1000 processor implementations.
I'm
So what's the problem with the existing version register?
well, that configuration bit to begin with is just stupid. I mean, the software shouldn't have to be encoded with, you know, some table of for implementation this particular configuration means X. We should have every single feature that's optional have a bit in some sort of presence register.
That's what the configuration registers are for.
Yeah, but I mean everything that's optional isn't in there, and that's another thing we need to look at. But I thought this was good because I forget.
You've forgotten why. It was jolly good.
I wrote this a long time ago. I decided to come up with something.
160 bits was to fit the Git revision.
Yeah, that's for a Git revision thing, but so yeah, the current I don't know, the current one just didn't make any sense. But I'm sure I had a rant on it somewhere.
Yes, you did.
So the one I'm proposing is another one. So we're not going to take the new one. So we're not going to replace the old one.
Which is register SPR 0, isn't it?
Yeah. We're going to add another one. So yeah, we should have an ID for the implementation, like them OR1KX or whatever, right, or OR1200. And then, what have I got? 8-bit version, so implementation specific version number. So that's like a release number or something, right? And then a CPU ID.
Which you say you've specified it as 24-bit and then talk about the 8-bit.
Yeah.
Oh, the original version register.
Yeah.
Oh
yeah.
right, okay, yeah, okay, right.
CPU ID, CPU identification is what's in. So you need specific identification. Presence bit, put it in the VR register. Yeah. Vision field. And those registers. I'm not sure what I'm going on about here. I'm pretty sure I posted to the mailing list with a more accurate description of what I wanted, but we just need an implementation number and an increasing version number. And then, because we all use Git, maybe a Git tag number.
So you've
or
got
something.
5 registers to hold a Git tag.
Yeah.
Well, that's fine. Why not just say 5 registers for a Git tag?
Well, you know, or you put whatever you want, like string, I don't know.
Yeah.
Because I think at the moment, the current registers don't make sense. What's this? Oh yeah, this is different. Okay, so alright, so I'm going on about version registers for implementations in the CPU because, you know, for instance, we could have like a version number for OR1K sim. We could have, yeah, Git tag, release number, something, I don't know, some sort of value for other CPU RTL as it's released. I don't know, a date that you built it on, I don't know. You can put a lot of useful information in these registers, which would be more useful than the system we have now, which is just confusing, I think.
I'm not sure we actually need to specify this much of the structure right there. It might be enough to just make sure we have a registry for implementations, those that are identified by the version register, and to reserve a certain SPR space for implementation-specific version information.
Yeah, fair enough. So, sorry, say that again. We go back, versioning registers. So we just have a new VR2, right? So we agree that probably a VR2 is good.
I'm not sure even VR2 is necessary in the spec.
I think because we're redefining what that register means, or what that field, the CPU ID means.
Yeah, I remember that Jonas was very opposed to changing this because in the Linux port it
Yeah.
was.
We can't change anything as it is because it's an ABI break as far as those guys are concerned. What we can do is like extend it, right? So add something that makes more sense. And we just have a bit that is set in a currently reserved part of the register, which then allows us to check in older implementations if this thing's there. If it isn't there, then I guess he'd give up and say, I don't know what CPU I'm on, I can't be sure. But for anything going forward, we can put in place mechanisms where he checks what implementation it is. Any known bugs in old RTL you can then check against because you got an increasing version number or release number or something. That's a good thing. I think that's what we want. But I agree, maybe we should just say we'll allow a set of registers to be implementation specific in terms of if you want to specify any more information. Like if you want to embed a string or something in the SPR space, you're free to do so, but it's implementation dependent. Something like that.
And probably fit the Perl script into those.
Right. So we agree to the basic idea that we can have the VR2 and a presence bit in the current VR in the reserved area, right?
Yes.
Agree that. And have VR2 with presence bit and currently reserved portion of VR. VR2's contents then. A version and a CPU ID is basically all I want. An implementation identifier and a version number. Are we happy with that? Do we think that's good? Okay, good. VR2's content, an implementation identifier and version number is what we want. Say. Or redefine meanings of current VR as this is considered an ABI break. Yeah.
What's the upper limit on SPRs? I mean, is it okay to just use 5, or is that are we booking up a big chunk of the available SPRs?
There are 64,000 SPRs.
Okay.
But they're in groups of 4K blocks, so 16 blocks, and you try and keep related ones and say there's a block for data MMU, a block for instruction MMU, and there's some structure in it.
But this will not, I mean, so 5 registers is...
It's not a problem, no.
That's
I mean,
not a huge amount.
no.
But
I mean, they're in the right place in the first lot of. They're in a logical place for the.
Yeah, and they're optional.
Yeah.
I'm thinking a set of 8 registers is probably reasonable.
Yeah, I think so. Maybe we could define a space or something. Operation current proposal is that.
So these are all in group 0.
Yeah.
I mean, the bottom 32 registers are all terribly specific. They're things like the unit presentation, the version register, the configuration registers, the program counter, the next program counter, the status register, the floating point controls,
Yep.
status register, the exception registers for the various contexts. And then above 80, There's nothing until you get to 1024, which is where the GPRs are mapped.
Yeah, yeah. So you just put it in that area.
Yep.
So I'm just going to say alteration to current proposal is that an area of 8 SPRs in group 0 is allowed to be implementation, defined, holding any sort of version.
So they suddenly got 8 now instead of 5.
Wow.
Well, it's,
Yeah.
it's a power 2.
Yep.
Yeah, yeah.
Works with me.
Holding version for implementation information. So, yeah, alteration of current proposal is an area of 8. It's allowed to be implemented. Implementation defined, holding any sort of version or implementation information. Okay, good.
So was that saying in addition, it's a further 8 registers? It's
Well-
not including. You might want to be clear that's another 8 registers, not the ones you've just been talking about.
To be clear, this
Is an addition. Is in addition to the VR2 and stuff you've just described
Yeah.
above.
addition to the VR2, not, and replaces the
It replaces the
proposed
rev
rev
IR.
IRs. Proposed rev IRs, which were deemed to be too, I don't know, specific. Okay. That's gonna be at the bottom. And then architecture versioning. That's the important one.
Oh god, I thought we'd cover all the versioning. Oh, we get more.
No, this is the second version.
Yeah.
Architecture version might be even more important.
I just realized that someone needs to write support for this too.
I should dig up my modeling scripts and finish the page references for the machine code.
So would it be a case for moving these ARC spec 2 out of OpenOffice and into like ASCII doc or something that's been done for the implementation specification?
I think it would be a good idea, but it's also a huge job.
Was it Ruben who did it with
No, it was this.
Emilio?
Yep.
One of the problems with the specification as it is right now is that some figures are created in some sort of non-free program and I can't edit them at all.
Oh, like VCO or something.
Yeah, something.
Yeah,
I don't know what this is.
make a screen.
What's it say when you write? When you try and open it, what's it? If you double click on it, what happens?
Sorry.
Well, it's just
It's an object.
Yeah, I would
Just
maybe rewrite that. It's not
do
that
it.
complicated.
Do it as a nice
Yeah,
vector
it's-
graphic, and you can. Yeah, you can.
I had some
Inkscape
problems
is,
finding.
is your friend.
Inkscape is indeed my friend.
Oh, I see.
but
No,
that job
I didn't. I just MD5 some of them.
Sorry, I know
So
architecture
there are
discussion
two.
stuff is riveting, but
No.
hey, so
Yeah,
this
go
is
back
quite
to
important, right? This is quite important because we are altering the architecture spec, so we need a way of tracking that, right? And figuring out what version we are, etc. So what is discussed here? We need a way of tracking it, as I just said. Although individual optional features will all have presence bits added, we still need a quick and easy way to determine roughly the architecture generation, right? So, a new register, the ARR, should be added at address 27. This is the proposal. This register will contain the latest architecture revision the implementation contains features from. This will allow the software to broadly detect which generation of CPU it is running on, and so which assumptions are safe. Does that make sense?
It's just a 32-bit number, is it?
Yeah, I guess so.
Do you want to actually be a bit more precise? I mean, are we following a major version, minor version, revision numbering process?
I think that's a
structure?
good way. Yeah, that's a good thing.
Have 8 bits each?
Yep.
Yeah.
I think, alright, yeah, so this is a separate thing.
So divide up the ARR
Yeah, yeah. I think major, minor.
you major, minor, revision, and what do you call it if it's a sub-revision? That gives you, then you've got 4 8-bit
Yeah.
slots, and when we get to the stage where we've hit above 256 with any of those, we'll think again.
Yeah.
If we release often enough, we will.
Yeah, that's quite often. If you want to be really pedantic, you could define all ones to mean look somewhere else. Or define all zeros, since we know we're past version 0, minor version 0, revision 0, sub-revision 0.
Yeah, yeah.
Yeah, so zeros means
4 8-bit fields containing
major version, minor
MSB,
version, revision,
LSB.
sub-revision.
Major, minor. What is it? Major, minor, release.
It's version, I think is the word, isn't it?
Major, minor. No.
Revision,
Revision,
sub-revision.
sub-revision, sub-revision numbers.
Yeah.
Revision, sub.
You major, I think you want version after words major and minor.
Major, minor. Okay. Major.
Version, minor version,
Major, minor.
revision, sub-revision. Numbers, okay.
4 8-bit fields containing MSB to LSB. Major version, minor version, revision, sub-revision numbers.
And presumably this architecture document probably ought to have those numbers in it.
The architecture document will contain a description of
These numbers on its front page,
Yeah.
because it doesn't at the moment. I think, oh actually maybe it does.
Well, that's the next thing, right? Architecture document version. Document itself will change over time. There needs to be a clear way of tracking that. As the document is amended at present, the document version, history table, and section 1.3 must be updated. However, the only way to track the document revision is by the recorded date of the edit. It's proposed a new column is added to the table with an entry for each document revision of the format XY, where X is the architecture revision in the document is added at that point, and Y is an integer beginning at 0 for each new revision and incrementing by 1 per document update. This would mean existing document revision 017 recorded updates since March 2000. The update corresponding with the addition of new features for the architecture revision 1 would mean the document revision would change to 1-0.
Why not just do it as a major, minor, revision, sub-revision and have it match the architecture?
What's a revision and a sub-revision? What's a major and a minor?
So major changes like GCC 3 to 4 where ABIs change in software. Okay?
Yeah.
Minor revisions have minor versions have significant changes, but they do not break ABIs. Revisions are below that, and I only put sub-revisions in because you've got 4 8-bit fields. So, I mean, some people do put sub-revisions for something that's piddlingly small, but I want to show it's changed. Oh, hold on. Oh, Bill. Oh, right. Who's?
This is the Microsoft version in the system.
Oh, Microsoft have major version, minor version, revision number, and build number.
Build. Well, this is an architecture, not an implementation. But
Yeah. Yes. So I got sub-revision.
build number. That's a good idea, actually.
Well, have the last one as build number. You're never going to use it anyway.
But I reckon, that's why I think we have a 24-bit this register, the implementation specific number, right? Because we were going to have 3 8-bit fields in there, major, minor, and say build number. So that would be good in the CPU, right? But for the architecture, we don't really need that many numbers, do we?
I'm just suggesting that
You really need a major and a minor.
I'm just saying it sort of makes sense to actually just have those two the same number. Actually, the architecture document and the architecture register should just be the same
Should
thing.
be in sync. Yeah.
So it should just be the same thing. So if my architecture is 1.2.3.4, my document describing it should be 1.2.3.4.
We need to define what those numbers mean, though.
Well, yeah.
Like major release, clearly. I think we will go from 0 to 1 when we do the update with this stuff, right?
Yeah.
Your minor release is adding features or something that are not too big. Then your third number would be like a document update, like we fixed a typo or something. Not necessarily corresponding to feature changes, but
Things like clarifications
yeah,
as well.
exactly.
Yeah.
So I think we only need 3 numbers.
Sure.
Picking 4 is just making.
Well, just make the fourth field reserved for future use, and then you've got
Yeah.
something for extensibility.
You want that in the top or in the bottom? I was in the top, so we can just throw away all the.
No, it's just
Well, of the 32-bit number you were talking about. Oh, I see what you mean.
I mean, we don't need to have more fine-grained things on the.
You may want to, yeah. I'll just the fourth, just to keep the fourth field as reserved, because you may use it as a marker in the future. The fourth field is reserved but set to 0, I would suggest at the moment. Reserved. Because then it
means in the future you can have it non-zero to indicate something's different.
Yeah, and I would like to have those in bit 31 to 24.
Do we actually have a clarification that reserved bits should be 0 somewhere in the document?
Yeah, I'm pretty sure, yeah.
Actually,
because we need that to define the reserved bits. As
I don't think we do define them to be 0. I think actually we don't mean reserved here. The fourth field is set to 0. It doesn't need to be reserved, it is set to 0. Reserved means it's not defined what it is.
Okay.
It's set to 0.
Because some bits are defined as reserved but reset value 0, like in the supervision register. While in the version register we have bits that are reserved but reset to X.
Yeah, I agree. Completely inconsistent, yeah.
I don't know, document clarification, typo and clarification and typos. Alright. The architecture will contain. Actually, one question is, how do we track this over time? What went in, right? So, you have a number. And the only thing that you can check against is like the architecture document. There's going to be a number on the front page of that or in a table or something. Where are you going to get a list of all the features of the architecture at that point in time?
On the same document?
Yeah, but the document evolves over time, right? Are we going to have to... Every time we add an architectural feature, are we going to have to say, as of revision XYZ, this is now in the architecture?
Yeah.
Something like that? Because otherwise you're going to get like, you know, a CPU with maybe, or like, I don't know, someone may get a CPU with a revision number that's not the latest. And they go to the document, and the document's for the latest. Oh no, maybe we do a release of the document per version. Per minor, yeah, release. Yeah, Jeremy, I'm asking, if you get a bit of silicon or something with a particular CPU number in it, right?
Mm-hmm.
How are you, based on the newest version of the architecture document, going to figure out exactly what feature set it has? Are you going to mark all the features that you add subsequently with this is now in from version XYZ?
Yeah,
or can we just do releases of the manual? Do you think that's better?
Yeah, just do releases of the manual and tag them in Git.
Yeah, okay.
Yeah, but I was looking at a little Python documentation. It's always like if this function came in at 2.6 and this function was removed at 2.3. And it won't be too many of these things. So it's.
But yeah, I think we should do both then. Mark additional features in the document with the version they are sort of current.
Yeah, that's a good design. That's good practice.
Yeah. Right. Will contain.
A note of the revision of when new features were introduced.
Yeah, we'll note the major we'll note the revision, the document, the architecture version that added features, that additions or major clarifications, changes were.
And you can go back on all previous versions for deletions and say this will be deleted in.
Okay. The document should also be properly release tagged per minor version update. I think that's not a bad little system there.
Good.
Because we can like now, you know, fix up the architecture and then be sure that what we're doing is sane. And at least track it. So architecture document versions, I said the same thing, it should just be in sync with. Should be in sync. Yeah, this is this. This should be, this document number should be in sync with the, maybe I don't need to catch that. It's human number will the same as the architectural version, whatever. Alright. Exception vector base address. I like this because my goodness, there is a lot of code space wasted in our below hex 2000 in OpenRISC. That whole space is just wasted, right?
Because
your vectors may not take up that entire space. And from 0 to 100, what are you doing there?
And that's the red area, what is it called?
It's the one.
No, pointer. There you go.
Sorry? That's, I don't know.
The point doesn't nearly 0.
I think it's bad, like the way that there's all that code area wasted.
Because it's using this for some internal pointer service, but it uses this space because it's there.
Yeah.
And Linux is using it.
Oh, okay.
0 to.
Yeah, we should
Cool,
definitely
cool.
stay away from the.
That's not the point of the
No, the
proposal. The proposal is that you can move it to. It doesn't have to
Yeah.
start at 0 or start at F.
you can start it at
What
3000 or whatever, yeah.
But you still get 256 bytes per vector.
Yeah.
Yeah,
That's just the way the architecture is defined. You don't want to go messing with that now.
yeah.
You know.
I think with a bit of additional work on the library or system, you can actually exploit it to just not jump away from the vector region for everything, but that's a software choice.
Yeah.
For me, this is a good feature because I don't like all that wasted area. It's down low.
But
This doesn't save you wasting area.
This address is not about that.
This
Yes,
is
it
about
does. This helps you with that, doesn't it?
no. It just says your 2000 hex 2000 starts at a different place.
This isn't a full address. You just got the space.
Yeah, so it says you're going at 4100, not 100.
So
Oh well, I propose it's completely configurable.
That's ORK. That's OR2K. That's the next meeting. That's the next discussion.
Fine.
that would mean making a list of the exception addresses.
Yeah.
Which we have. You know, those exceptions aren't going to change, and it wouldn't be that hard to put in a bunch of registers and a register of bits to say that I've removed that one. But anyway.
I'm not sure it's actually worth it for current implementations.
But anyway,
I
I think it's neither has.
This is excellent. It's what you need to make things like ROM-based bootloaders that
Yeah.
can switch over to.
We do have that though. We have the EPH.
Yeah, but that's.
But you've only got
like
it's inflexible.
hacked in.
Inflexible.
Yeah.
Yeah. Okay.
So this is to solve that, to put it through whatever.
Yeah.
Mhm.
All agree this is good. Okay. Ooh, instruction classes.
Fine.
Oh, yeah.
There's two, yeah.
Does anyone want to say anything?
My worry about this, about having vast number of classes, is it completely screws you on multi-lib.
No, but the idea is we just do one minimal and then one fully blown.
Well, so most people will say, oh, I'm sorry, you've got hardware multiplication and division, but because you haven't got C-sync, you can't use them.
It's not really going to have C-sync.
C-sync.
Well, C-sync's in class 5. I just picked something from the other end. I mean, if you're only going to have, if you're going to have these classes, it's presumably because some people have them, and you want to be able to use them in the compiler. And it strikes me that therefore you're going to need a multi-lib for each one. Okay, I'm going to need a multi-lib to say, yes, I've got multiply and divide here. Otherwise, what's the point? If I've got bit manipulation, I mean, you can argue the case, maybe there's a case for pushing stuff that's not ever going to be used by a compiler out there. I mean, you're presuming the compiler's never going to generate C-sync. CMOV is incredibly useful instruction for compiler. Why it was never in class 1, I never understood. But,
Yeah, it is.
yeah. I mean, CMOV should be in class 1. Seems a much more useful change to make.
At least for the kind of pipeline that implementations that exist as it can be useful.
I mean, the ones that actually matter are multiply and divide, because they make such a big difference to silicon space, and they make such a big difference to performance.
They don't. They're not that big, really. You get hard macros in FPGAs.
In
I suppose,
FPGA,
yeah, maybe they're not. Okay, yeah.
That depends on where you implement it.
Yes, on ASIC, they
and
would
it's
take
not
a
an
lot of
action.
space.
Also, you might have an FPGA case where all those are already taken up for other work.
If you have mull and div, you absolutely want them to be used in your libraries because they make such a huge difference.
But can we move things to class 1 now, or will that destroy everything? I mean, everyone seems to want to move CMOV, for example.
Yeah.
I can't see it's a problem because the only thing this affects people implementing as to what they have to implement. But we're talking, this is for future anyway, and it goes in this was moved to class 1 in revision, whatever. And maybe there are some legacy issues with the compiler.
So in terms of implementation optimization, I'm far more inclined to just chuck everything these days, because as I've shown, it's very hard to make like a processor that's less than a few thousand lights anyway. What's a few hundred more? For at least optional bit manipulation.
I mean, yeah, if you're making the case that in fact none of these make a significant difference in FPGA silicon space, then shove the lot in and just have class 1 and be done with it.
I reckon. But then again, maybe you could have
But is anyone going to do I mean, OpenRISC, we always run it Linux and we do it in a Linux environment, but is there ever a mileage in a smaller OpenRISC? Or
Yes.
Yes, we have a lot of requests that we want OpenRISC to be
so you
smaller.
want a core instruction set that you can do a low area
And
low
actually,
power.
control purposes or whatever.
what I said before isn't entirely true. If you add up the costs of a divide and multiply in Vertex 5, what do you got there? You've got
That's quite a lot of LUTs.
serial divide, full multiplier costs 550 baht. So that could be almost a quarter of your resource
Oh, right, okay.
in your CPU going into this. So If you're doing a really small implementation that was just doing control.
Those two, I would definitely say, should be optional.
Yeah.
Yeah, you sort of want multiply and divide. And if you have multiply, does divide cost a lot more as well? I mean,
yeah.
it does. So you
Because
really
we're
want
doing a
the same-
serial multiply algorithm which has like 64 registers or something, you know, maybe more.
I mean, you could do an implementation where you could use parts or share parts, but I guess most.
I don't know enough
cases-
about how hardware's moved on. I mean,
In the PDP-1, it was essentially the same logic that did multiply and divide, but now you generally have dedicated multiplier blocks, which are not so easily used
Yeah.
for division.
I mean, it sort of says that you want what's your core instruction set, which I think is the old class 1. Then you want multiply and divide, and then there it's almost like class 2 has multiply, class 3 has divide as well, and then you want everything else.
Sort of tempted to put all these ones in class 1.
Yeah, but remember, what's the purpose? If the purpose is to have the smallest possible, those don't make much difference to compiled code.
Yeah. Nor to area.
I mean, if they really, yeah, I mean,
183 LUTs in Vertex 5.
okay, so
It's maybe 10 or 20% actually in a very, very small implementation. Like I showed. In Spartan 6 you also, well, let's do the here you've got. This is
Spartan 6, that's basically the same silicon as the Vertex 5, right?
No, it has lot 6s.
well, sorry, this is Vertex 5. So this OR1KX takes up 2,000 LUTs and 700 registers. So, and that's without hardware multiply or divide. So this is the small one.
so how much was it in total? 2,000, you say?
Yeah, about 2,000.
Are you counting the?
So you'd add another
So without these things, so you'd add another 10%.
Yeah.
6 lots in
Yeah.
Vertex 5 too.
Was that including the I/O registers?
Good question.
Because that can be deceiving.
But we're mainly looking at LUTs here, not
Okay, yeah.
because there's no LUTs on these ones. Oh, no registers. They're all purely combinatorial, like decode, all just arithmetic stuff. I don't know.
The more classes you have, the more your multi-live issue becomes one. I'm not sure how much a compiler would use those instructions.
Yeah, find first, last, extension. Oh, rotate right. Isn't that used a bit by compiler? I don't even know why this
I
is
don't know.
optional.
You need it this way. You need to. Yeah, not online. Is it?
I think they use the shifts more.
L. No. I'm not sure. Anyway.
He was sending messages at
2 can be used by the compiler at least.
2 o'clock in the morning.
Right, okay. I'm not sure I've ever seen them emitted, though.
No, GCC doesn't emit that. I don't know. VM does.
Ah, okay.
There is actually not a flag to not emit them at the moment. Should be put them. But yeah, you can use them, so they are.
What about those extension instructions?
Yes, they can be used too. I haven't explored them.
They're not emitted by GCC.
To some extent. I have a bad understanding of some of these instructions.
I don't really know what all the sync ones do.
Me neither.
Like I guess the M-sync's like a memory barrier or something. Make sure that all the memory ops before that instruction are complete before you go on. Is that right?
Aren't these all tied in with the multiple contexts stuff?
No, not at all.
Not
Actually.
What's C-sync?
Cache sync.
Oh.
P-sync is pipeline sync, or
P-sync is pipeline sync, right? Yeah.
Yeah.
So if you've got anything out of order, maybe it makes sure that all that's done.
It forces the pipeline flush and reload.
Right. Okay.
But those are not ones you're going to computer generate. You might compiler generate Mac instructions.
Oh yeah, Mac ones. I believe that was a
Only
separate
when the
class.
Mac is useful and it's not in the current architecture.
Sorry?
Only if the Mac is useful and it's
Oh
not
yeah,
in the
yeah,
current
yeah, yes,
architecture.
yes. It comes in the category of we haven't implemented these.
No, they are implemented. They're just useless.
Oh right, why are they useless?
It throws away like half the multiplier, doesn't it? Or something?
It throws away half the multiply result and then stores it in a registry you can't access.
But other than that, it was quite a good design.
what a fucking waste of gates.
Yeah.
Maybe
So-
that should be on.
I'm a
this
proponent
page.
of changing what the multiply accumulate unit actually does with it.
I reckon out of this discussion we have determined that C-move should be class 1.
Yeah.
Probably those optional bit manipulations should also be class 1. And then we should have 4 classes.
And Mull and Div should each be a separate class because you may want to have one or both.
Oh no, I reckon you've got either.
Well, they were
hardware-
quite big, weren't they? That was the point.
Yeah.
Is
It's
that you
unlikely
might.
to have a divider without a multiplier.
Yeah, sorry, I meant yes, either Mull or Mull and Div. I wasn't.
Okay.
Yeah. Okay. I'm presuming that they are incremental. That you cannot have class 1 and class 3, but not class 2.
Oh no.
Multiply.
Painful.
Yes, the polting. Oh yes.
Sorry. All right, fine.
So
Well, I suppose class 5 doesn't matter because you're never going to compile them. But
how much of the stuff do you need to redo for different? When
so you
multi-lib?
don't have to have a multi-lib for every class combination. You, in fact, you'd be mad to because combinatorial. You'd have 1,000 different multi-libs, and it would take you 3 weeks to recompile the toolchain. But you do get you have a real problem of controlling combinatorial explosion. I would guess you want a class 1 compiler. You want a class 1 plus mul compiler. You want a class 1 plus mul plus div library.
And then delay slot and no delay slot.
Yeah. And then you have well
Very important.
yeah, except those are yeah.
That's not
Yeah,
structured.
But you wouldn't have multi-lib because you're either doing one architecture or the other. So you either build a no delay slot toolchain or a
Yeah,
delay
it's
slot
just how it's
toolchain.
set up now. It actually builds them multiple side.
Yeah.
Hey guys, we obviously can't add too much to that particular discussion, and probably the next one as well. So we thought we might just head out and see some Stockholm. Actually,
Come back
We
to
don't
us
have a plane. Yeah, so.
and come back for some bug squashing in an hour.
I don't know. We have a plane today
Oh.
in the afternoon from Skavsta. So
All right.
if
Okay.
that's okay. I
That's
mean,
right. Yeah.
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 No, no.
to stay longer.
Yeah.
We shall miss you. But, you know.
We didn't know it would be
Just
so-
don't
so
change
detailed.
any important stuff that
Yeah.
will
Don't
destroy
break Ecos, and then
Ah,
you're fine with your
Oh yes, the bit.
proposition.
Yes, proposal to delete ecos. Yes, we haven't got to that one.
Do not vote for that. We're not here. But
Yeah. Cool. No worries.
Well, it was really great.
Yeah.
Yeah.
It's
Nice
good
to see you guys.
come.
Hopefully, it will be like more than
Maybe-
one each year. Or
Peter proposed actually that we could hold some kind of teleconferences every now and then, like every month or two,
Yeah.
and do the work in between those, and then on the meetings only agree. Like for example, the cache problem. Like everyone was kind of agreeing what it was. Somebody could just propose the change, and then people say yes or no, and either say it's getting in or it's not getting in.
Yeah.
But, and that part would be done during the meeting, but not the actual big discussion. Whether-
Oh, it's useful to have discussion though. while we're
yeah,
doing
yeah,
it.
sure.
So,
Yeah.
um,
That's an idea to have occasional phone conference.
But yeah, phone conference.
Yeah.
Yeah, then I can be naked.
Exactly.
At which point it becomes a video conference.
so yeah, no worries. Cool.
Good.
I've got some things to suggest for ECOS, but we can do it on the mailing list. So that's
I
alright.
would definitely do that. I mean, it always gets lost in translation when you do it immediately. tell somebody what's broken.
Yep.
Yeah, we'll do some bug squashing around in Ecos and pretty soon, I guess, so that we don't forget.
Cool.
Good.
Alright guys, very nice to meet you.
Have a good trip back.
Yeah, thank you.
Thanks for coming again.
Thanks, man.
Cheers. Cheers, Peter. Enjoy Stockholm.
Thank
you. Bye.
Bye.
Yeah, see you. See you. And we'll talk some more.
Yeah.
Right. Our side version 3 is really interesting. Nice meeting you.
Same.
Oh yeah, just not to leave us down.
Yeah, we probably won't solve the whole instruction class issue, I would guess.
No, I'm noting what we've come up with, which is basically CMove should be class 1. Class 3 should be class 1 implementation if overhead is considered to be not too bad. Is that something we've agreed on?
So where were your comments, sorry?
On this page, we think that L.move should be class 1.
Conditional move.
Yeah, L.cmove,
Yeah.
sorry.
Yeah, okay.
Class 3 should be class 1 implementation of it.
You mean class 3 should be added to class 1?
Yeah.
Yeah, okay. Well, I mean, if the guy's doing small things, reckons it's not going to be significant, that's fine.
Well, I don't think the rotate is that much of an extra cost when you already have the barrel shifter.
Yeah.
Yeah, okay. Okay.
It is costly, but
But you have to have the shifter anyway. Yeah. The other thing we had was about having. I think you have a class 2 that is null and a class 3 that's null and div.
And if it's incremental,
Well, the reason I've done it like that is because it's not incremental. Then you can have class 1 and class 2, or class 1 and class 3. And the other ones, well, maybe one day you'll. The Mac is in a mess anyway, so maybe we don't have to worry about it yet, because you could compile for Mac. On class 5, you're never going to compile anyway.
yeah.
you would not compile for Mac currently because it's no more efficient than using multiply and add.
Yeah.
Alright. Oh yeah.
And then you've got L.sfi and L.trap.
Because they're listed as class 2.
Does the compiler generate them?
Yeah.
Set flag, yeah. Trap, don't know.
No.
No, but I mean, the compiler doesn't generate syscall or anything like that.
I mean, L.trap you need for the.
Debugger.
I do so many different architectures. I forget which instruction.
We
Trap's
do
what
not
we use the breakpoints.
syscalls. We have L.syscall.
Right. Yeah. Okay. Yeah. Yes. It's confusing because I think they're named the other way round in Arc. So.
Yeah.
Okay. Okay. Yeah. So you want L.trap because you need it for the debugger for soft.
Yeah. I'm saying put them in class 1.
Yeah. How much space does the set flag immediate take up?
Oh, you have to have it. There's no way you can't not have it.
Well, there are ways you can have it, but it carries a compilation.
Yeah, it doesn't make any sense.
It doesn't take
Okay,
any
right, fine,
extra
yeah.
because you already have the
You already
immediate
have,
builder.
your comparison logic
Yeah, okay.
and your immediate extraction logic, so it's a little bit more muxing.
Okay.
Well,
Maybe.
it's less of an exception, really.
Yeah, I think it's a mistake that was to be.
Okay, so they made class 1, yeah. So we end up with a class 1 and then
And then a class
2, which is null, class 3, which is null and div.
Do we all agree on that? If there's consent, if there's more people for it than against, I think we do that. But I reckon just leave mull and div together or completely without.
I don't know enough about the implementation to know whether there is actually a demand to create something with hard null but not div. From a compiler point of view, I'd much rather have fewer classes. So if everyone agrees that if you have null, you also have div, that's fine. It's worth. I mean, it's something we ought to be a little careful about because actually the default Verilog always was that you had a null but not a div.
The point with the div is that usually they are serial divs, and you can almost make as fast software div. Or, I mean, the difference between a hardware multiplier and a software multiplier is a lot bigger than the difference, because you're still gonna have some, like,
Because the
simple serial divider, you're still gonna have like 32 cycles to perform the divide.
And you're still going to have it in software because the module operation is not available in the instructions.
Yeah, that's true.
And how you, but how, I see you said, oh yes, that's just measuring it. But of course, if you do put a divide in, presumably you're doing it because you really want it to go fast, and you're not going to put a simple serial divider in there, you're going to put a serious division hardware, and that uses space like there's no tomorrow, which is a case for saying, actually, you either have mull, or you have mull and div, and they are two separate classes, because the only reason you do a hardware div was because you wanted to do a seriously fast one. Because otherwise, you, as you say, do it in software. So it does say make them separate classes.
And yeah, you probably need to have the hardware multiplier to do this.
Yeah.
Is this the case for two classes then?
Yep.
Yeah, anyway. See you guys.
How was it?
Thanks again for coming. Yeah, you too. Go ahead. Thanks.
Time limit because that's not classified as a camcorder.
Sorry?
You get 30 minutes
For
to
tax reasons, the camera stops recording after 20 minutes or something.
Oh, right. Well,
I don't really want to make any decisions right now.
no, I'm just documenting.
Yeah, but can
Probably
we agree on that for the mull and div that we leave it to next session?
Proposal.
We need
of-
more
Okay,
user
yeah.
stories, I think, to see.
Yeah, okay.
Okay, documented that. We agreed that set flag immediate and LDOT trap should be class 1.
Yes.
Cool. Alright. I propose the next thing is presence bits for all these optional instructions that you can't determine via looking at what classes you have.
Right, oh yeah, I mean, I didn't like this of individual instruction. I mean,
But it's only for the final ones.
All the custom instructions are implementation specific anyway.
yeah, so
Only one of them is defined in the architecture manual, and I don't even know why.
I think
that
that's
is.
only as an example, isn't it?
Yeah.
Well, so you think there should be bits in the implementation register saying whether you've got L.cost.
I mean, but if you've got L.cost1, you've sort of got to write a whole chunk of architecture manual and everything to say what it is, what its format is, what its structure is, and everything.
That could be in your implementation manual.
Yeah.
And so what you specify in the implementation specific area of the SPR space, what that means. I'm happy to do that. I'm happy to leave it to the implementation to
And-
define
Yeah.
I think it's appropriate.
whether it's present.
Because generic code which would detect the features present really couldn't use them anyway.
Yeah, you're right. Okay.
Conditional move with the grid
Yeah.
should be
Elements
required.
removed.
The sync instructions, maybe they should be knobs when they are not implemented. I'm not sure.
I mean, would you actually perhaps implement C-Sync but not M-Sync, or M-Sync and not P-Sync? Would you?
Yes,
Yes, okay.
currently P-Sync is implemented. I don't think C-Sync really is. I'm not sure.
I'm not sure any of those are actually implemented.
Well, P-Sync is implemented in the OR1200. I can't speak for others.
Which is P-Sync?
Pipeline sync.
Okay.
so it causes a pipeline flush
Yeah.
and reload, much like any exception does. And of course, you could patch all the sync instructions out of your code if you find they're not implemented.
So that would leave us with something like,
How do they look in machine code? Are they actually hard to decode?
Well, they also C-sync and P-sync.
Yeah.
No, they're easy to do. They're the same as trap. They're in the same group as trap.
Because in that case it might be better to specify their behavior, well, that they may be not being in the cases where you don't actually have a meaningful implementation.
what's being discussed, sorry, whether we not want
They're all in the same group of machine code instructions. So the case with P-sync, M-sync and so on is that they are rarely emitted by compiled code, but they are for barriers and such.
Yeah.
And if you have the functionality, they should obviously be implemented. If you don't have the functionality, then they should simply be ignored. So maybe we should specify them as optional effects, not as optional instructions.
Yeah. Okay, so in fact you don't need to say there. You don't need these bits, then, or these bits say whether it'll do anything.
Yeah.
so
Where is P-sync implemented? Wrapping for it doesn't show any.
P-sync in the document, in the RTL?
And,
Oh,
It's a bit disguised, I think, since it affects the pipeline and not the execution unit as such. It's spread out, I believe. But it's first found in the decoder and
yeah, these X-sync things.
handled by the exception handler or something like that.
So if you grep for X-sync. Oh, I don't want to control, there you go.
I'm not sure it actually does anything different for the three, but
I mean, oh no, but yeah, that's decoding for syscall, because that's in the same group of instructions.
yes, it is.
And that's trap.
It's syscall, trap, and the sync instructions.
Yeah, but I don't think the syncs do anything there. I'm not sure we're decoding for P-sync anywhere. Anyway. Yeah, I mean, that makes sense that not optional instructions, but optional effects.
I think you can find it if you look how flush pipe is generated, but it's a bit of a mess.
Okay.
I'm sorry I'm not so clear here, but I remember actually digging for it and eventually finding out that P-sync did what it was supposed to.
Okay. Well, said optional effects. Let's just say that, right? I think that's a good proposal.
Okay.
So, if, and here I'll say if sync.
Oddly enough, they are also specified as 32-bit instructions, exact values.
Yeah.
So decoding that would be expensive.
Yeah. Sync instructions are listed as optional effect, then we don't need them here. So it would end up with just a bit indicating support for groups of instructions only. That's pretty good, I think, if you just got to register with bits saying classes supported, right? So, something like this. Where I proposed, which register should this go in the CPU CFGR.
Makes sense.
Yeah. So we'll leave it at that, shall we?
Yeah.
Last thing, delay slot. Well, actually, maybe not last thing. Delay slot.
I think a lot of this here doesn't have anything to do with the architecture manual, because it's all about GAS and GCC, and we don't talk about GAS and GCC implementation in the architecture manual.
But it could be mentioned in the...
It can be mentioned in the discussion here, that's fine, yeah.
It's allowed to make an implementation that doesn't have in place.
And I think you've got to have a way to detect that from the software.
Yeah, I'm not arguing against the architectural stuff.
Yeah.
But we don't say what the flag should be on GCC for any of the other features. And so forth. I'm also you're making a mistake here. You can't make up your mind whether it's a new target or it's a flag, and it should be one or the other. ARC made that mistake of having both, and they have a completely broken tool chain as a consequence. Either it's an architectural feature and it's a genuinely different target, or it is an option to the compiler to say, I don't have delay slots, I do have delay slots, and you can do either. I'm inclined to say do it as the flags, because I don't think I can immediately think of any other architecture that has a different target for whether or not it has delay slots.
I think it would be a waste to make it a target.
Yeah. Typically you have a different target for big endian and little endian. That's the one way to do it.
Also have flags for
well, some architectures do have flags, and I say ARC made the mistake of having both, and consequently gets in a complete mess. Am I running the big endian architecture? Well, yes, you have. Do I have the big endian architecture with the little endian flag, or the little endian? You can mess it completely. ARM has a separate architecture target.
ARM and ARM.
Yeah.
Delay selection, generally agreed upon, architecture, specific, suggest a proposal.
Yeah.
Point made, the decision must be made between either having a different target in the toolchain or just a flag to indicate that delay slot code should be generated. But no delay slot code should be
and the other point I made is that it isn't the role of the architecture manual anyway. There's a separate manual about the design of the toolchain. The ABI is in the manual, but this isn't an ABI thing. I mean, these are all perfectly reasonable things to say.
It doesn't say anything about if you have flags or how you do with the hardware multipliers and stuff like that.
No,
So
exactly. I mean, they're perfectly reasonable things to discuss and have something. It's just not in the architecture manual.
The architecture manual should specify the configuration bit for no delay slot and its consequences.
which I think we have that on machines where CPU CFGR ND is set, then this is the consequences.
Yeah, that all looks reasonable.
Perfect. Alright. Atomic instructions, you added this, didn't you, Stefan?
Yeah.
What are you thinking?
I think it would be nice to have.
Alright, let's put that in.
And if you want code to be portable to either, you just put a knob after every branch.
Yeah, on the delay slot. Yeah.
Is there a way to grab the mailing list? I'm pretty sure we came up with a proposal for this.
Atomic operations, yeah, there was a discussion of it, wasn't there?
Yeah, something along the lines of a load link store conditional and a bit in an SPR that we test to see whether...
I just...
oh, no, sorry, just store the state of the load link, we have a bit in the SPR to determine. And so if you've got a context switch or an exception during that operation, I don't know, isn't it your store conditional just fails?
Huh?
Isn't it just your store condition?
Yeah.
Store conditional will return 0 if it didn't work, right?
Yeah. But there's like 2 different roads, but I can say I have read up on all the benefits and what's good and bad with the other one. But you can have load store conditional, or you can have what I voted there in the discussion.
You can either have that, or you can use it from your R&D, so that will be like a compare exchange. Yeah, that's how I'm doing.
Well, I've got the mailing list going back to last November, and I can't find the word atomic in any message.
I don't think we have had any discussion.
There was a discussion somewhere about
R&D,
maybe.
I just remembered an example of a thing that breaks with no delay thing. Your code for loading the PC value.
I know.
So, okay, so we've just got dynamic linking working. It breaks it.
In the well, if the compiler generates that code, well, in GTT it's broken, but LLVM, for example, when that generates that, it's not going to emit the knob. So there it still works.
On that battery.
Yeah, but that means the code has to be specific for the no delay swap version.
Yeah.
Yeah,
but they're compatible.
But the independent code is not compatible with running on either delay swap or no delay swap.
I know that. It's a bit of a... I don't know how to fix that actually. But
well, I have an instruction to copy the program into the current instruction.
Huh?
If we have a different way of loading where this instruction executes.
Yeah, well, we could actually do it with a SPR, but
can't you do it with a jump and
but that this encourages the manual
changes what the link register points to when you do a jump and link.
Really? You shouldn't read the PC out of the SPR.
But doesn't it sort of self-counter? As in you want it to be 4 different anyway.
Probably it's hard to do.
No, because the point of doing that jump and position is all the code is finding your position.
Right.
Yeah, you know why? That's not good. Is it really?
But you can do it as a relocation anyway, and just do it as an absolute value. And have the linker tell you, the dynamic linker tell you what your position is by putting that value in there.
Or probably read my right. Which do you reckon is better? I'm sure. What I've read is that there's some kind of disadvantage with loading store. But I can't say that I usually that I thought it. So I was kind of hoping that someone else would have really
The person who would know about this is Stefan Valentovich.
Yeah.
And I think it'd be worth sending him an email.
Yeah, but okay, so I just want to throw this out because it's useful to have, and Linux people have mentioned that this is annoying that it's missing in OpenRISC.
Yeah. So, Julius, I remember what it was. Wasn't it you met someone at a conference who'd explained why this sort of thing we got wrong in OpenRISC? Someone was telling me they'd had a conversation about this stuff at a conference with someone who knew all about it. It wasn't you.
I think it might have been me, but I think it was just someone saying, "Oh, you need it." Like,
was that at the workshop? It's called workshop. Related to the
I don't remember.
stuff.
You get a lot of people coming up telling you there's stuff missing. Remember that guy?
If you don't have it, it's gonna be through some lib calls, and that's of course gonna be slower. And I'm not sure if some cases where you actually really need to have it, because otherwise it's not like.
But this becomes important when we become multi-core and stuff.
I believe that it's then, but it's still a beneficial thing to have, from what I have understood, even if you're not doing multi-core.
Okay.
So, yeah, the discussion that I wanted to have was more of a, would it be okay to start a discussion that, okay, we might want to add them, but what kind of, that's a bit open still.
I don't know, I think I'd thought it's pretty obvious that we need them, because we can't go multi-core until we have got them, and multi-core seems to be the thing that keeps on coming up. How do you do a multi-core OpenRISC?
I would go with with atomic load linked store conditional, because then it keeps in the RISC thing. Read, modify, write seems like a big fancy op you're going to have to sit there, install in your pipeline and do, you know.
Yeah. It's out of my field, I don't know enough about that.
Because, you know, read, modify, write, you're going to sit there and put the RTL into your load store unit to somehow, you know, check on the bus that sideband signal coming in, you know, is good. And
I mean, you guys in Bristol are always doing multi-core stuff, man.
but that's just me, but I don't know enough about it.
I don't know. Sort of thing. I thought David may probably have strong views on how we should do it.
I've said on the wiki that we should continue this discussion on the mailing list.
Yep, okay.
Does that mean lunch?
Yeah.
Lunch.
And I think that probably concludes the session.
Yep. Thank you, Julius.
No, thank you.
We've blown out almost everyone.
Yeah. You're hanging in there, Frank. Good on you, mate.
Right.
So we got this out of it.